Welcome to the Dr. Gabrielle Lyon Show, where cutting-edge science meets innovation and practical application for everybody. In today's episode, I sit down with my friend, Dr. Allison Brager. Now, she is a neurobiologist. We talk all about sleep. This is not your typical sleep conversation. Dr. Allison has extensive information and experience with military special operations, and what we learn from her, it's not about in the perfect world how you sleep, but when things go sideways. And let's face it, things go sideways all the time. We do not live in the perfect world where we can sleep 8 hours, wake up, meditate, do our normal morning routine. We learn everything you need to know about sleep and beyond. Please sit down with me in this conversation with Dr. Allison Brager. Dr. Allison Brager, welcome to the show. I am thrilled to have you on. Actually, we've been trying to connect for, has to be a couple of years that I have just been begging you to come on, and here you are. Welcome.
Thank you. Yeah, I think it's been at least 8 years, right?
I have followed your journey. So you're a PhD, you're a neurobiologist. You're going to have to tell us what that means. Also, wanting to be an astronaut. So up for astronaut selection, which will be amazing.
Yeah.
But please tell us a little bit about what you do.
Sure. So I have training in neuroscience. I was fortunate. I went to undergrad at Brown University, which at the time had like one of the only neuroscience programs outside of Harvard built into their undergraduate curriculum. So I had no choice but to get exposed to neuroscience because it was built into psychology, it was built into computer science, it was built into like every part of the curriculum. I knew I wanted to either go to med school or do a PhD. But after I started working in an adolescent sleep lab, I realized, I definitely really want to pursue this further. So I got my PhD in neuroscience. I worked with, he's now retired, but he was the world's expert in understanding non-photic or non-light cues that entrain sleep and circadian rhythms. So he had a big focus on exercise and all the neuroanatomical brain structures and pathways involved with how that happens for entraining sleep and circadian rhythms.
And really ahead of his time.
Yeah. What's crazy, right, is he had done this work since the 80s, had about 3-4 decades of continuous funding from the National Institutes of Health. But one of those things where you're studying such a complex area of biology, but with no I would say societal recognition or like awareness, right? Because it ends up in, although flagship, but highly technical journals.
Yeah. And also now it seems that circadian biology is really taken off.
Yes.
And the influence on our health is really great. Tell me a little bit about what you're up to now.
So I actually am an active duty neuroscientist. I've been doing that for the last 8 years. I started at the Walter Reed Army Institute of Research. Right now I work with Army Special Forces. And really it's just taking the principles and practices of neuroscience and neurobiology and applying it to improving safety, increasing performance, and even bettering overall health and wellness of our warfighters. So we do a lot of unique studies where we're either doing, for example, biomarker captures to understand how we can use that to improve safety and performance, or we'll even be involved with new use cases for existing medications. So we do a lot of randomized clinical trials around existing, for example, sleep medications, and repurpose those medications in collaboration with the FDA for use in combat situations.
That's fascinating. Can you give me an example of
Yeah, so one of the studies that we, when I say we, this is the team back at the Clinical Trials Center at the Walter Reed Army Institute of Research, so back in DC, is doing a head-to-head comparison of the pharmacology of suvorexant. Trade name is Belsomra, so it's a Merck drug. It is an orexin antagonist versus your classic standard sleep hypnotic or benzodiazepine like Ambien or Lunesta. And so when you look at the pharmacology of Ambien or Lunesta, it is extremely long half-life, right? And it's global inhibition of the neurochemical GABA in the brain. So if you are in a situation where you are overseas and you're under fire and you have to wake up in the middle of the night, well, when you wake people up at peak blood concentrations of this drug in the middle of the night, they're essentially drunk. Their vigilance, their cognitive ability to process even basic tasks is impaired because that drug stays in your system for so long. So one of the things we know about these new age sleep medications like suvorexant is it's a very targeted effect, right? It's only impacting orexin receptors, which only lie in very specific parts of the brain, largely the hypothalamus. Like the lateral hypothalamus, for example. And so when you wake people up at peak blood concentrations under this drug, they're able to maintain their vigilance. They're able to regain their cognitive capacity. And they don't have that feeling of grogginess or drunkenness like you have with the classic benzodiazepines.
Thank you to Timeline for sponsoring this episode. Of course, it's January. And remember, with January, everybody decides to set goals. We're not doing that. We are setting a core standard philosophy for healthy muscle, and it starts with healthy mitochondria. There are various ways to go about hitting your 2025 muscle standards. This includes a great nutrition program, resistance training, and of course, supplementation. If I were to pick one supplement that helps support healthy muscle and mitochondria, it would be MitoPure. MitoPure is a precise dose of a postbiotic urolithin A. It works by promoting essential cellular cleanup and helping clear out old dysfunctional mitochondria. Timeline has done an incredible job at leading the way with science first to bring the only urolithin A supplement on the market that is clinically tested to target the effects of age-related cellular decline. And when you start taking MitoPure, what might you feel? You might feel better energy levels, faster recovery, more endurance, better strength, all of which help you achieve an excellent muscle standard. And in our family, we've been using MitoPure for the past couple years, and it is a staple. Timeline is offering 10% off your order of MitoPure. Go to timeline.com/Dr. Lyon. That's timeline.com/Dr. Lyon. You know, is part of your work figuring out when to use these agents to go to sleep, for example, if, you know, and I think not necessarily about the warfighter, but what about people that are shift workers or moms or people that have to be functional at night?
Oh, yeah, absolutely. I mean, right, we all know like postpartum, like lots of sleep issues, and a lot of women are actually prescribed, hypnotics to help deal with the consequences of sleep deprivation. I really think this is another use case of these drugs, and especially in shift workers, right in the hospital, firefighters, police, huge application there. And even for, people who are jet setters who travel around the world as part of their business and work. That's where I think these newer age sleep medications that have a much shorter half-life can really benefit them, because you can at least get a few hours of sleep on the plane, and then when you wake up, you're less groggy. Like, of course, it's not the highest quality sleep, but
don't complain, because you're going to be able to wake up and be functional.
Right, yeah.
What else are you working on?
So,
as if that's not enough.
Well, I mean, a lot of the work I do now is more in the biomarker space. So looking at biomarkers that are sensitive to hypoxic stress, both peripheral hypoxic stress and then central hypoxic stress, central meaning like impacting the brain. And then we're doing a lot of work. We were just interviewed for ABC nighttime news a few weeks ago about the blast over pressure work. So finding ways to prevent, monitor, and enhance the brain function of those who are impacted by repeated low-level blast. That's still a really mysterious, complex area, right? We don't know if blast over pressure is directly linked to these neurological, psychiatric, behavioral symptoms that a lot of operators are experiencing. But through the continued work, through our academic partners who are doing neuroimaging and all these highly complex, sophisticated studies for us, we're starting to uncover hopefully, associations or correlations with repeated low-level blast.
And that will be so great for the operator, and probably then can be translated to those in sport. Obviously,
absolutely.
Obviously, they're not, football players are not undergoing blasts, but definitely the continual head trauma, really being able to think about ways in which we can protect people.
Yeah. So actually, we are just, it's funny you bring that up, and I forgot to mention this. So we are about to send on a study that I was the principal investigator for back when I was at Walter Reed, where we were looking at how a single concussion impacted sleep architecture and sleep physiology in the long term. So at the time, we had a great partnership with Johns Hopkins University and their athletic staff, where as soon as there was a football player who had a concussion, they would refer them to us, and we would enroll them in a study where 3 to 9 months after they had experienced this mild concussion and effectively returned to play, they would then come into our sleep lab. We do an overnight sleep study. We would then sleep deprive them for 40 hours, which seems insane. But if you think about operators, right, when they go out on the X, they're awake for days on end. And one of the things we found is their sleep architecture, even long after they return to play, has never quite recovered from the concussion. So their baseline sleep, less restorative sleep, so less deep non-REM, slow wave sleep. And then that during the sleep deprivation period, their performance essentially unravels. So at certain time points, they couldn't effectively do basic tests of reaction time, or they had reduced reaction time. But if they got sufficient sleep again, then all those behavioral impairments went away too. So it really did kind of show like sleep being a mitigation factor for those who've experienced a concussion. But also pointing out that once you have even a single concussion that we're aware of, that you may never, or that your sleep architecture has a difficult time recovering from that.
So prevention is probably best. I think there's probably also some data on transmagnetic stimulation.
Oh, yes.
For recovering somewhat. I don't know if it's so much sleep architecture. We had Dr. Eric Wong on, and do you know him?
Yeah, I do know him.
I think that maybe we were all together. Were we all together at Global Special Operations?
No, I know of him because he's been involved with the community for a long time.
Yeah, he's amazing, and he talked a lot about just recovery of brainwaves. I want to talk differently about sleep in this podcast. I'm going to tell you why, because we hear how important sleep is. You cannot turn on a podcast where people don't say, oh my gosh, you have to get 8 hours. Don't have caffeine after, 2 o'clock. Well, the reality is that's not always possible. And you have really helped people operate in austere environments, in environments where it's not perfect, where you can't wake up and do your 10-minute meditation followed by Tai Chi plus your breathing plus your foot massage and then your gratitude journal.
Yeah.
So please tell me, when we think about the impact of periods of sleep restriction and potential ways in which we can overcome whatever those outcomes are that are bad for our bodies in various ways.
Yeah, I mean, really, I think that's the overarching theme of all the work that the sleep scientists hired by the Department of Defense do, not just within the Army, but across the board. So our team of military, uniformed sleep scientists and civilian sleep scientists, because we recognize the reality of this problem. So I sort of see it as a trifecta. So you have sleep itself, right? The only thing that can replace lost sleep is actually sleep.
And can we make up for that?
You can. So that is a myth. right, it takes dedicated time and practice. We know for every night of insufficient sleep, it takes 2 nights of sufficient sleep. So if you're looking at career-long shift workers, for example, you're talking about decades of good, actual quality sleep to recover that lost sleep. But that's also where napping comes in. So, we have this joke in our community. We call it the GBTNT, so Green Beret Tactical Nap Time.
I've never heard of that.
Yeah,
GB
TNT.
Green Beret Tactical Nap Time. Okay.
Yep.
We're going to put that into our family motto.
Should.
Okay. What
You
happens?
should. And so a 20 or 30-minute nap under periods of chronic sleep restriction does actually help repay off that sleep debt. I mean, it's ever so slowly, but it's better than nothing. And if you look at athletic performance, mood, and even cognitive performance immediately after a nap, even under someone who's chronically sleep deprived, there is a time window where performance does improve.
And how do we define chronic sleep deprivation?
So the clinical definition, at least according to the American Academy of Sleep Medicine, is it's less than you think. So it's basically a week. Like essentially, if you have a whole sustained week of insufficient sleep where you're getting 6 or less hours a night, you are considered to be chronically sleep deprived, which is laughable, right?
Yeah.
Because
I mean, I don't know the last time. Okay. I mean, 6 hours of sleep, is that continued sleep? Is it?
Yeah. So just 6 hours within a 24-hour period. But which is why if you look at like the recent health census that the CDC has done, and I know the National Sleep Foundation has done some, like greater than 70% of Americans, just focusing on Americans, have insufficient sleep, i.e. chronic sleep loss. So that's how at least we define it clinically, especially when we're doing these laboratory studies. So if we do a chronic sleep loss study, like I talked about with the head-to-head comparison of the pharmaceuticals, that's essentially what we put our participants through is they get 5 hours of sleep over a 7-day period. Sometimes we'll extend that out to 2 weeks.
5 hours of sleep over a 7-day period.
Mm-hmm. Yep. Yeah. Historically, that's what has been done in the field for decades.
And when someone naps, someone is getting, they have sleep restriction, sleep insufficiency. My producer, Matt, he probably doesn't sleep much, but I do know that there's some genetics, and we're going to talk about that, that some people genetically can do fine and just don't require sleep.
Yep.
How do we take someone who is sleep deprived? When is the best time to put in naps? And could it be 8 minutes? Does it matter how long it is and what time of day?
So first golden rule is no more than 30 minutes at a time. If you do longer than 30 minutes, you want to do 90 minutes.
How come?
Because that is the length of a full sleep cycle.
Is everyone's sleep cycle the same?
Yeah. So 90 minutes, historically from, again, years and decades of work that was done in the 50s and 60s, just to characterize human sleep physiology, we know that the human sleep cycle, once the brain is, fully matured, is 90 minutes.
That just eliminated half the population. I'm just kidding. Kidding.
And so the reason you don't want to go past 90 minutes, right, is because then it increases likelihood that you'll have an inability to like fall asleep later that night, because you've essentially, there's 2 components to sleep. We call it a homeostatic component and a circadian component. And so if you're extending the sleep cycle past 90 minutes, you're potentially stressing both systems, both the homeostatic and the circadian. So when we do these sleep interventions, to your second point, we only want to stress one of these components, right? So when it comes to a 20 or 30-minute nap, you're most likely to fall asleep if you're in that circadian window of decreased alertness, which for most people is in the middle of the afternoon. It varies by person because everyone's internal biological clock ticks differently. I'm a vampire, so my clock is a little bit slower than 24 hours. So for me, I usually get sleepy naturally between 3:30 and 4 p.m. Someone who's traditionally a morning person and genetically a morning person, they're probably going to get sleepy between 1:30 and 2. And so you really just have to find that time period where you're paying attention to your levels of fatigue and alertness and capitalize on that and use that as an opportunity to sleep.
And if someone were to do a nap, a GBTNT, Green Beret Tactical Nap Time, would somebody then require less sleep?
So I wouldn't say require less sleep. It's just more repaying back that sleep debt because, again, probably greater than 70% of the time they are chronically sleep deprived. Now, in someone who has a absolutely perfect schedule, like you described in the beginning, then yes, they're adding, you can think of sleep as a bank account, right? They're adding credits to their sleep account. And so hypothetically, if they keep doing that, then they don't need as much nighttime sleep because they have credits to spare. But most people are quite honestly in a state of chronic sleep debt. So napping is helping them repay that sleep debt.
And could someone also do less than 20 minutes and still, would there be any efficacy in
Yes. That? Yeah. So we haven't, I'm not sure of the research in terms of looking at the optimal dose of napping, under a 20-minute duration. But I do know of research of if you're someone who truly can't nap because psychologically you just can't wind down, someone who practices either meditation or does deep breath work, something where they're essentially slowing down their brain waves, right? That is also effective for increasing immediate performance and mood afterwards, whether they're an expert meditator or not. So just giving yourself that ability to take, as we call it, an operational pause, can go a long way instead of just trying to use coffee and caffeine to masking.
Is there something wrong with that?
No, I mean, so there is a thing actually, and there has been science that we've done within the DoD to study it. It's called a nappuccino. So essentially this was popular during the 70s with the truck industry, where if you give people coffee before they take a 20-minute nap, it takes 20 minutes for the coffee to reach the adenosine receptors in the brain. And so you can use that period to nap with having limited impacts of the caffeine on your brain. And then when you wake up, you feel refreshed and less groggy. So there were studies that were done within the DoD to show that when subjects were doing that their reaction time and their ability on cognitive tests with increasing difficulty actually was better.
For operators, is that a strategy? Are there particular protocols that, say, you guys use for the operators that we as civilians could benefit from, similar to that?
Yes. So actually, I'll bring this up. So we helped transition an app to the public a few years ago. It was called Peak Alert. It essentially was a culmination of decades of research on strategic caffeine dosing. So randomized clinical, double-blind, placebo-controlled trials we did in the sleep lab at Walter Reed under acute sleep deprivation, so greater than 24 hours of wakefulness, chronic sleep deprivation, all different doses of caffeine. We've done genetic studies to show how your genetic landscape shapes your sensitivity to caffeine.
Meaning, is that a COMT SNP, something like that?
Yeah. So one of the SNPs, we looked at COMT. We also looked at TNF alpha. And then, of course, ADA2A, so the adenosine receptor, the 2A receptor, which is the receptor that caffeine effectively binds to.
Which I think you have
I have
adenosine on your arm. I noticed that earlier.
Yeah, I do. Yep, that's my little, I always try to get a tattoo in every place I'm stationed with relevance to the work I do. And so this is my adenosine receptor. And then we also did field studies too. So we actually partnered with the Ranger Training Battalion. So the group of Ranger instructors who essentially run Ranger School. And we did a strategic caffeine dosing study with them as well. And so all this data was rolled up into an app. where essentially you can go in, you take a baseline test of reaction time. That's gold standard to look at how sensitive you are or how sleep deprived you are. It's called the psychomotor vigilance test. And so after you do this 2-minute version of the psychomotor vigilance test, where essentially the test is you have to respond to a red dot on the screen that's presented at random intervals. So we know people who are sleep deprived, they react more slowly to the dot, or they'll think it's there when it's actually not there.
And what is the app called?
So it's called Peak Alert. However, you can only use the web-based version now, which is To Be Alert. The reason it doesn't exist anymore is I learned recently from one of the developers that the government didn't pay the bill. So it used to be on the Apple App Store, Android App Store, but it is no longer there. That was the story. I can't confirm or deny.
Without the app, how are we going to figure out our caffeine dosing and our strategies?
So you could use the website still. It's called tobealert.org.
Okay, we'll link it.
Yeah.
All right. What makes Cozy Earth different? Number one, temperature regulation. Cozy Earth sheets are so breathable that you'll sleep several degrees cooler. The fabric is amazing. It has durable weave fabric that won't pill, and also it's guaranteed for 10 years. It is soft. And not only that, it has this, bamboo viscose, which is what it's made from. And every time you wash these sheets, it becomes softer. So it's not like that, those other sheets that you wash a million times and they all start to fall apart and they should be called uncomfortable earth. Cozy Earth is not that. It is bedding and bath products that have a 10-year warranty guarantee. Again, they are bamboo sheet sets, 100% premium viscose from bamboo, breathable sheets, uniquely and softly tailored to you. Get softer with every wash. And not only that, 100-night sleep trial. Yes, you can sleep on it for 100 nights and get a full refund. Wrap yourself in luxury this fall. I know that I'm going to. So you guys send me some more. Go to cozyearth.com/Dr. Lyon. You'll get 40% off your purchase. That's cozyearth.com/Dr. Lyon. And if you get a post-purchase survey, say you heard about Cozy Earth from this podcast, and who knows, maybe you'll get a surprise. How do we think about using caffeine and sleep? There's a lot of information out there. Delayed caffeine intake, don't take caffeine at this time, dosing strategies in terms of this is too much versus not enough. How do we think about it?
So I come from the camp of researchers because of the work we've done at Walter Reed. Again, work in the lab, work in the field, that you can have caffeine as soon as you wake up in the morning to help combat the effects of sleep inertia. Now, I know...
What's sleep inertia?
So sleep inertia is essentially the clinical term for grogginess and waking up feeling, lesser than your peak self in the morning. We all experience it, right?
Is there any way around that?
So, no, everyone experiences it when they wake up, whether they're sufficiently or insufficiently slept. But someone who has insufficient sleep, their sleep inertia will be more prolonged. So instead of the usual 5 to 10 minutes in someone who gets sufficient sleep,
I'm like, you're talking about an hour.
Right. You're talking about an hour or so. And that's really where caffeine is helpful, right? So, I know there's this sentiment out there about the waiting 90 minutes after you wake up in the morning to consume caffeine.
I've never actually heard that.
So that is one of the protocols that has been put out there. But if you look at that study, the rationale behind it is apparently through a mechanism that I still can't wrap my head around. It is supposed to help stabilize cortisol levels throughout the rest of the waking day. However, this study that was cited is a very small sample size study, and the research participants only abstained from caffeine for about 5 days. And then 2 days after waiting to have their caffeine, the effect was abolished. So to me, that's not really practical and or relevant because most people consume coffee every day. But what we're a fan of really, especially for sleep deprived populations, is having caffeine as soon as possible. which is 200 milligrams. So that is the one thing I failed to mention from the 2B Alert app is of all the years of research we did in the lab and in the field with caffeine, 200 milligrams is the ceiling effect, whether you are caffeine tolerant or caffeine sensitive. At that point, you have saturation of the adenosine receptors.
For everybody.
For everyone.
And we know that to be true because when I think about, let's say, testosterone, some people have a greater expression of testosterone receptors versus other people. And so someone could, those with really high testosterone receptor expression, androgen receptor expression, they can require less testosterone.
Yeah.
But caffeine is not the same.
It doesn't appear to be the same right now. I'm not sure if research has been done to look at like individual variability and the density of like adenosine 2A receptors within the brain. But I can say like the general common theme of, we're talking like 40, 50 different publications and different studies in this area. 200 milligrams seems to be the ceiling effect. So you can do 300 milligrams, but you're going to get the same effect.
But you're just doing that for vanity purposes.
Right. Yeah. So you can have, your pre-workout, which most of them have 400
280
milligrams of caffeine.
Yeah. No.
Yeah. I've seen upwards of, 450.
That's important to understand that you're not going to get any benefit above and beyond that.
Yep.
First thing in the morning, you wake up, you have your energy drink, which we're going to end up talking about, or coffee or something.
I have coffee, yeah. French press.
French press. You hit 200 milligrams of caffeine. Is there something else that will then also increase alertness? Do you have to go outside, get sunlight? I mean, you do a lot of work and have done a tremendous amount of work on circadian rhythm and circadian alignment in terms of how it helps regulate overall performance in the body.
So it's caffeine and, right, I guess I got off track with the trifecta, blue light exposure, right? Like, yes, sunlight preferred. Blue light also works, especially, up north, right? That's the worst part about living in New England is when it doesn't get light out until 8:30 a.m. and it's, dark by like 3 p.m. Blue light exposure just for 20 minutes. You can buy a cheap blue light box. Or if you're fortunate enough to have sunlight in the morning, go out and be in sunlight for 20 or 30 minutes.
But it's the blue light spectrum. So it's blue. And does blue include, is it just blue? Is there blue, red, various other full spectrum that's important?
Blue only. Yep. Sunlight is a different mechanism of action, right? Because
I don't know that, really.
Yeah, well, if you think about it, like you think about the conservation of sleep in circadian biology, it feeds back to like human evolution, right? And like we didn't have blue light and artificial light back then. Like our most sensitive time cue was sunlight. And there actually is a study that one of the renowned circadian biologists did showing that he took basically college students camping and he took them camping for 2 weeks. And during that 2 weeks of camping, their melatonin rhythm of secretion and release and their subjective and objective levels of sleep were absolutely perfect. And then when he tried to expose participants in the lab to the same intensity of light that was mimicked as students who were camping, it was not perfect.
Do you think there is benefit to, it's going to sound crazy, but to sleeping outside?
Oh, absolutely. Yeah. I mean, I think whatever you can do to mimic how life used to be like hundreds and thousands of years ago, because evolution does not proceed that quickly, right? The better. Like I would say this is more anecdotal. This is not clinical, but there's anecdotal evidence for like grounding, right? And sleeping on the ground compared to sleeping in a nice fluffy, on a mattress.
Sounds uncomfortable. But this is really funny. My dad is interesting. He was a scholar.
Okay.
And he went to Wharton, graduated top of his class. Okay. He was a collegiate wrestler, captain of his wrestling team at Penn. And then after a series of years, decided that he was done and then moved to Ecuador.
Okay.
And he's somewhat of a mountain man.
Okay. Yeah.
if he has the opportunity to sleep outside, you better believe this guy is outside.
Yeah.
Sleeping. Even when he comes to visit me in Houston, if I were to put a cot upstairs on the balcony, that guy will sleep outside.
Yeah. No, so anecdotally, I will say I've experienced that too. So when I was in graduate school, I was dating, and I was actually at one point married to a tropical ecologist. And so my boyfriend, ex-husband, now like would go out into Costa Rica. He still does that today for 6-7 months in the rainforest and capture changes in, I don't know, different ecological factors out there. So we would go into these super remote, austere field stations. And, you know, in Costa Rica, it's close to the equator. So you get 12 hours of light, 12 hours of dark. And to this day, like, sure, I was in my mid-20s then. I have never had such better sleep in my life than those months of, you know, being out at this field station in the Costa Rican rainforest.
There's something, you know, we have become very domesticated.
Right.
And it's just normal for us to be, for example, we're in the studio, there's lots of bright lights. I'm sure over time it affects us in ways that, I don't know. I mean, are we evolved to be able to manage that? I'm sure it is at some point stressful to the body.
Yeah.
20 minutes, 200 milligrams of caffeine. You don't care the source, right? Doesn't matter the source.
So we can use this as a platform now to talk about energy drinks. Like if,
as long as we make sure that we don't miss the opportunity of our protocol of how to wake up.
Yes, we can save that for, but I'm a big fan of coffee and green tea, right?
Rippets on base?
No, God, no, not Rippets. Actually, the amount of caffeine and like the tiny little Rippets you get while deployed is sufficient caffeine for morning wakefulness. It's just the ingredients may not be so healthy, but we know with, you know, coffee and green tea, right? The neuroprotective factors, antioxidant factors. I believe there's a longitudinal study to show that people who are at risk for dementia and early onset Alzheimer's, if they were chronic coffee drinkers throughout their life, that they were essentially neuroprotective from reduced risk for dementia and early onset Alzheimer's.
And that's from the polyphenol components.
Polyphenol, and then also the other neurochemical that people don't recognize when we're talking about caffeine is acetylcholine, right? And the acetylcholinergic breakdown of like the tangles that appear in the brain with Alzheimer's, those are acetylcholinergic tangles. And so if you have coffee and you're exercising, those are two big things that promote acetylcholine release, but also just like the structural integrity of the acetylcholine neurons.
What is after that? We've got the blue light, 20 minutes, 200 milligrams of caffeine. Do you care about food? Because I do know that food is somewhat of a circadian entrainment when you're thinking about protocols that you give the guys that are going out there to make things happen.
Yeah. So the circadian components of food, I will say I am less knowledgeable in this area. But one thing I do know is you don't want to have like high glycemic food before you go to bed. So there are studies to show that if you increase blood glucose before your actual sleep onset, that you're more prone to sleep disruptions because you want to actually go to sleep with low blood glucose rather than high. Outside of, when to eat fats, when to eat protein, in particular, that I would say I wouldn't say I've stayed away from it, but I haven't.
Fair enough.
I haven't
you weren't
researched
choosing,
it enough.
You weren't waking up and choosing violence. I understand.
Yes, exactly.
Anything else? After that first dose, how long does someone wait until they have their second dose? And what is the total amount of caffeine one could ingest, or what is optimal in those who are not getting enough sleep?
So in order to have sustained performance, or try to have as sustained performance as possible, even under sleep restriction, it's every 3 to 4 hours that you have 200 milligrams of caffeine. So if you went on the To Be Alert website, and you looked at the strategic caffeine dosing protocol that it gives you, it would more than likely say, hey, you should have anywhere from 150 to 200 milligrams of caffeine every 3 to 4 hours, but stopping at least 6 to 8 hours before bedtime, because we do know the half-life of caffeine for most people is between 4 and 6 hours.
This episode is brought to you by Manacora. Now, man flu season is here, also the season of sore throats and viruses. I'm all about remedies provided by nature and products that have dual action. Now, thank you to Manacora for being one of those dual action products. It has a special antibacterial compound in it called MGO, which comes from the nectar of the tea tree. Manacora is third-party tested. They test every single harvest for MGO and makes these results available. For my family, we use this incredible honey in our tea for sore throats and its medicinal properties. We also use it anytime we need a sweetener. I feel like I'm gaming the system. My kids love the creamy flavor, and I'm giving them something packed with antioxidants. I personally use a little packet before I speak on stage or podcast because it coats my throat. The bees collect the nectar from the Manacora tree. In New Zealand, the nectar is packed with bioactive ingredients, and the honey that is in it is produced, has 3 times more antioxidants and prebiotics than your average honey. Sign me up. I am all in. It's like a honey with superpower. Now, it's easy for you to get honey from these bees and for you to try Manacora honey. Head to manacora.com/Dr. Lyon to get $25 off the starter kit, which comes with an MGO Manacora honey jar, 5 honey travel sticks, a wooden spoon, a guidebook. It's amazing. Try it. That's manacora.com/Dr. Lyon for $25 off your starter kit. Got it. Before bedtime, do people have various caffeine tolerances?
Yes. Right. Like, obviously, if you are a chronic caffeine drinker, you're going to have tolerance. But even if you don't drink caffeine that regularly and say you have it on a 3 or 4 day schedule, you're going to have what we know as rapid tolerance. One of the things we could bring up, because we did do a randomized clinical, double-blind placebo-controlled study, is your genetic attributes and how that relates to tolerance of caffeine. So this is a study that I ran. I'm first author on the paper when I was at Walter Reed. And what's unique about this study is it's actually probably one of the longest, most aggressive protocols of sleep deprivation ever, but it mimics what we see in the operational environment. So even when I was deployed, not myself personally, but what those around me experienced, which was 48 hours of continuous wakefulness. So full on 2 days of sleep deprivation, 3 days of recovery. So essentially our participants were getting 8 hours of sleep. We know that does not happen on deployment, personal experience. But then again, 48 hours of sleep deprivation, 3 days recovery sleep, 48 hours of sleep deprivation again, 3 days recovery sleep.
How are you keeping those guys up?
Just
caffeine?
Yeah. So if they
Caffeine,
were lucky enough,
nicotine, modafinil, we're using
just caffeine.
other
Or not,
stimulants.
depending on, because there's a randomized study, right? So sometimes they got caffeine, sometimes they didn't. Our research research assistants were very good with trying to entertain the research subjects, but without providing time cues, right? They couldn't watch TV because they know what time it is. They played a lot of board games, did a lot of arts and crafts, things like that.
A lot of scrapbooking.
A lot of honestly, whatever silly games we used to play as kids to keep them entertained.
There was no screen use aside from knowing time. Was there some reason that you were concerned that it would affect melatonin production or any other biomarker?
Exactly. So when we do these sleep deprivation studies longer than 24 hours, we minimize screen time or try to mask it in some way, right, to reduce the white light and blue light because of disrupting melatonin release. So what these research subjects would do is every 4 hours they would get caffeine or not. They didn't know if they were getting the placebo or 100, 200, or 300 milligrams of caffeine. And then they would do, again, the psychomotor vigilance test. They did mood scales, like all the subjective things of sleep deprivation. And then we also had them spit in a tube, so we can do like a genetic capture of what we call SNPs, or single nucleotide polymorphisms. Those are naturally occurring mutations in the genetic code that contribute to genetic diversity in humans. And so one of the things we found is with a SNP and TNF alpha, which is a major inflammatory, a major factor of inflammation, we found that people who had this one particular SNP of it were more resilient to sleep deprivation, meaning that when they were doing these cognitive tests throughout these repeated cycles of sleep deprivation, they performed better than those who did not have that unique SNP. But they were no more sensitive to caffeine. So what I mean by that is, for those who didn't have that unique SNP, caffeine could help raise their performance to levels of those who had the unique SNP. But those with the unique SNP could not raise their performance even more. So essentially, they couldn't be super soldiers. They couldn't be resilient to caffeine and sensitive to sleep deprivation, which is really unique because we've seen this in other SNP studies too. There really are, like, the human body's so fascinating. There's these genetic trade-offs that, like, we don't know why they exist, but they do. And so this is like a unique thing we found with this SNP with TNF alpha.
Okay, so what I'm hearing you say is that some soldiers had SNPs that they were resilient to sleep deprivation, that their performance remained, even if, is it that they didn't have caffeine, or is it they're more tolerant to the actual sleep deprivation? How do we determine which?
So they're more tolerant to the actual sleep deprivation. We determined it in two ways. One, in the in-lab study, if we looked at time points where they were actually given the placebo and not the caffeine at a certain time point within the sleep deprivation, their performance was still better than those who didn't have this unique SNP. And then it just so happened we were able to effectively translate this work when we did actual studies with the Army Rangers.
And I want to hear about that, because that's fascinating. You had mentioned before that, before we started recording, that you looked at a group of Army Rangers and they all had the same SNP.
Yep. They had the same SNP as these. And we had just like going into the study blind, right? We were just, it was part of a study we did when they were doing a training exercise. Army Rangers, they operate at night, they seize airfields. When they do these operations, they're awake for essentially 40 hours, if not more on end. All these SNPs that we had studied for years in the lab at Walter Reed, when we looked at their SNP profiles, and, COMT was another one we found, but the same genotype that we found in the lab mapped in the field with TNF alpha.
It was insane. That's fascinating. Yeah. Basically, what you're saying is, certain people are almost genetically selected to be able to do that job.
Oh, absolutely. And so with the work I do, even now, people don't like to hear my messaging, right? Because it does, I wouldn't say it dismisses hard work, but like what I say is, that expression, like, talent doesn't work hard when hard work works better. Like, if you have the hard work and you have the talent, you're unstoppable. And so a lot of people don't like to hear, Ranger School, truly what I think Ranger School is, it is selecting for people who are genetically resilient to sleep deprivation. It's the same thing with special forces, right? You know what I mean? Like, they have a unique genetic landscape that makes them who they are. And it's all about just finding what genetic landscape works for you. Look at the same thing in Olympic athletes, right? Like, one of my favorite books is The Sports Gene, like deep dives into different unique SNPs and genetic attributes that makes an elite high jumper, that makes an elite cross-country skier or Jamaican sprinter.
I think it's fascinating because there is the hard work and yeah, we're all going to do that, but right, you're not going to become a ranger or get through buds or do any of those things without having the mental capacity. But genetically, some people will be able to tolerate sleep restriction.
Yep.
Who knows, more caffeine, probably more stress, and we could define stress in various ways. And that's fascinating.
Yeah.
And one has to think, okay, well, people will talk about how food moves the needle on genetics and environment moves the needle on genetics. But do you think that there is any crossover for being able to move? And I don't think so. And I don't want to be Debbie Downer, but could somebody deploy various nutritional strategies, various training strategies to change or flip these genes?
Personally, from at least my knowledge in molecular biology and genetics, I operate on the same camp as you. Like, you can help create the environment and shape for these genetic markers to fully be expressed to the capacity they can, right? Because, right, food is helpful in mitigating like DNA methylation and, all of those factors. But I think your genetics are your genetics. And, it sounds like a Debbie Downer answer, but from the camp of research I come from, that's what we see. That's what we did in preclinical animal models when I used to do the genetic engineering in mice. And that's what we see in human models,
It's really fascinating. And it's not to say that you can't be amazing, but you might be somebody who requires sleep. And also the genetic component, it might be pushing in other directions. For example, I don't know, disease prevention, if you have enough vitamin A, or improving B vitamin methylation. But when it comes to your tolerance for sleep deprivation, I don't know, do you think there are other markers as well?
Oh, so we see that with stress too. And we see that, work with hypoxia tolerance, with altitude tolerance, all those factors to extreme environments. Yeah.
Basically, what we're talking about here are two separate camps. We're talking about the interplay between environment and genetics.
Right.
Talk to me a little bit about hypoxia and various other genetic interplays between environment and a human.
So that's actually where TNF alpha is one of those, very unique inflammatory factors that also plays a role in hypoxia. You also have, reactive oxygen species, and you have hypoxia inducible factor, so HIF alpha. We're starting to do a little bit of these studies now with combat divers. A little bit of this work has been done in like experimental dive pools and other hypoxic environments, to include altitude, within the Department of Defense over the years. But those are the three biomarkers and factors that we see routinely in all these studies in terms of whatever someone's baseline levels of these three are.
And they are TNF
alpha, reactive oxygen species, and HIF alpha, so hypoxia inducible factor alpha. That time and time again, under these extreme conditions of hypoxia, whether subsurface or altitude induced, are directly related to one's personal inter-individual tolerance to hypoxia. And performance after, right? Cognitive performance, physical performance, susceptibility to altitude, sickness, for example.
It truly is fascinating. One of the other things that you really played a big role in is understanding and your work in the BMAL1.
Oh, yeah.
That's function in skeletal muscle mass, regulating sleep deprivation. Can you talk a little bit about that?
Yeah. So this is actually why I was so excited to be on your podcast, giving your very rich history and research that you've done in skeletal muscle physiology. So this is, I guess, my claim to fame in the sleep field, and no matter what work I do from here on out, this is like what I'll be known for. So essentially and this wasn't just me, like I was a postdoc in the lab at the time, but I was the lead for the project. This is a collaboration between me and my postdoc mentor, Dr. Katema Paul at Morehouse School of Medicine, and then our collaborators at UT Southwestern, Joe Takahashi, and then Karen Esser, who's a skeletal muscle physiologist. She's now at University of Florida. So essentially, we know that every single tissue of the body possesses a self-sustaining biological clock. So you have the central biological clock in the hypothalamus of the brain, known as the suprachiasmatic nucleus. But then there are a series of peripheral clocks that have essentially been identified in every tissue of the body, to include even fat cells. And so Karen Esser, she's the one who discovered the biological clock in skeletal muscle and found the same circadian clock gene factors that create the self-sustaining 24-hour rhythm. We took her model and essentially, through the help of Joe Takahashi at UT Southwestern, genetically engineered a mouse model where you could disrupt the expression of these clock genes in either the brain or the skeletal muscle. So it's through this really unique mechanism where you could turn on and off the genes by giving the mice doxycycline, because the expression factor known as operon was essentially turned on or off by doxycycline. I don't know how they thought to do this, but that was like how they did it. And
wake up one morning and have just a
I don't know. It's
genius morning. I don't know.
Those people, those are the real geniuses of the world. Like, I can never think of something like that. But
I don't know. You might up in space.
I don't know. Maybe I'll use these mice up in space, right? But essentially what we found from this work, when you looked at sleep, just normal spontaneous sleep in these mouse models with the manipulation of these clock gene factors, and then under conditions of sleep deprivation, when you disrupted the circadian clock in the brain of these mice, you had very limited impacts on their sleep architecture and their resiliency to sleep deprivation.
Wait, what does that mean?
So essentially, if you looked at a wild type mouse, and then you looked at a mouse that had disrupted circadian clock, there was very few changes in the amount of slow wave sleep, so what we call in humans deep non-REM sleep and REM sleep in these mice. But when you looked at the disrupted clock in the mouse with a disrupted clock in the skeletal muscle, there were very pronounced changes in sleep architecture at baseline. And then when these mice were sleep deprived, you saw a reduction in their rebound response to sleep deprivation, which essentially is like a reduction in slow wave sleep, which can essentially mean that they're replenishing their, under conditions of sleep deprivation, when they have the opportunity to recover again, these mice essentially had a faster recovery from sleep deprivation. And then when we looked at, neurochemically what's going on, it's because they have heightened levels of acetylcholine and wake-promoting regions of the brain. What's also unique about these mice is that they were essentially super soldiers. So if you did an exercise tolerance test with them and you put them on a treadmill, believe it or not, there are researchers that do this. They have little boxes separating the treadmills, and you let them run to exhaustion. The mice with this unique genetic expression in the skeletal muscle, and only the skeletal muscle, had a far longer latency to exhaustion by hours. They would just run for hours, and then when you do a resting energy expenditure capture, just metabolic
That's
capture.
Incredible.
Yeah, it's insane. They have more fat producing pathways. So they're basically bred somehow to be hyper ultra endurance athletes.
I recommend taking Puri O3 Ultra Pure Fish Oil. Why? because I did my training in nutritional sciences with a heavy focus on muscle health. Now, there is an abundance of evidence supporting the use of omega-3 fish oil in overall health, muscle, brain, mood, the list goes on. I won't take just any omega-3 supplement. I only want the best quality fish oil. And that's why I've been using Puori. This is the ultimate in high quality and high class brands. Puori O3 Ultra Pure Fish Oil is third-party tested. I trust it to be free of heavy metals and other impurities. Every batch of Puori O3 Ultra Pure Fish Oil and all of their supplements are tested against more than 200 contaminants, with all their results published online. Now, I worked out a deal in exchange for sponsorship. They offer you guys, my listeners, 20% off store-wide. What's even more amazing is that even applies to the already discounted subscriptions. You'll get almost a third off the price. But in order to get this offer, you'll need to go to my exclusive URL, which is puori.com/Dr. Lyon, and use my promo code Dr. Lyon at checkout. That's PUORI.com/Dr. Lyon. You guys will love this brand. And I have some notes from this study. So the study is BMAL1 function and skeletal muscle regulates sleep. Mm-hmm. And you looked at the circadian clock gene, right, BMAL1, in sleep regulation with a specific focus on its expression in skeletal muscle versus the brain. When we think about translating that, if we can, to humans, can we? Is there a translation potentially to humans?
Anecdotally, we've kind of seen this in ultra runner populations because long after this, I was working with my lab mate from grad school, who is an ultra runner who works with ultra runners. Like, this is kind of like we haven't genetically, genotyped these ultra runners, but phenotypically they have these attributes that we've seen in the BMAL1 mice, like with increased expression in the skeletal muscle.
Do you think that that there is a role for exercise? They talk about there's two things about skeletal muscle I think is really fascinating. One is that it seems as if someone is under chronic sleep deprivation, or even let's say they go through periods of sleep deprivation, that hard training seems to offset that sleep deprivation. And that sounds very nebulous. Maybe you can explain a bit more about that, but
so there is research.
Yes.
There is research to show that that is one way to offset the immediate cognitive and physical impairments you see with sleep deprivation. It's only a short-lived effect.
Meaning you couldn't continue to do that.
Yeah. So after that bout of exercise, if you gave them the psychomotor vigilance test, you looked at mood, all those things, that would be sustained for about an hour or two. But then that effect is abolished. Now, mechanistically, I can't speak to how that happens, but I'm sure increase epinephrine, norepinephrine, cortisol, all those things that are feel-good, wake-promoting hormones,
and
impact that.
Yes, and I think that we need more research. The other thing that I had two other thoughts. And this kind of circles back to the genetic landscape, and you were talking about rangers. Mm-hmm. Do we think that is also there for females? I'm assuming that the rangers were all male.
Yes. Yeah. At the time, right? There are over 300 women now in the Army who have a ranger tab. There's still not many assigned to the ranger regiment, though. But
do we think that they also express the same gene? Do you think they're sex specific? I have no idea.
So these genetic factors are robust across sex. We know that because all of our studies that we have done at Walter Reed, unlike other researchers who've only studied males for a very long time, we have always had equal amounts of males and females in lab
That's
studies.
That's really unusual.
Mm-hmm. Yep. I don't know. We led the way in that area. Because we control everything else appropriately. And it's the same thing with these mice too, right? They weren't just all male mice. They were male and female mice.
Okay.
Yeah.
Would a reasonable translation be that muscle somehow signals realignment of circadian rhythms or may help promote sleep? Do we think that there's some way that we can think about when we utilize exercise, the kind of exercise that we use to help with sleep?
Yeah, so this is, after we discovered this, so Dr. Paul, he's still like, I would say like a mid-career researcher now. Like once he had this finding as an early career investigator, I mean, he is taking and running with it, right? Because just figuring out what this mechanism of action is. And we've gone through different things, like, is it Orison, the factor Orison was one we thought of. But that's his baby now, right? I wish I would have stayed in his lab. But it does, bottom line, there seems to be some biological factor in muscle that is promoting resiliency to sleep deprivation, or shaping the environment of, again, this mammalian species in a way where architecturally within the brain that it shapes the landscape to be more resilient to sleep deprivation.
And is muscle, is BMAL only in muscle?
So BMAL is, so to clarify, BMAL1 is the positive transcription translation factor of the circadian clock, no matter what tissue. Yeah. So there's two positive factors, BMAL1 and clock, and then there's two negative factors, PER and cry. And so that's what creates that self-sustaining 24-hour loop.
I ask that because, through periods of aging and sarcopenia, as individuals lose a lot of muscle.
Yeah.
And if we think about the percentage of body mass that muscle is, then you would drastically reduce the expression of muscle BMAL.
Yeah. So actually, I'm so thankful you said that, because that is something that I know Dr. Paul is trying to look at now, is looking at an aging mouse model, because anecdotally and clinically, we do know that like loss of muscle mass is associated with poor sleep outcomes. And this might be the mechanism of action. It's just, this finding came out like, 6-7 years ago. So I think we still have a few unfortunate decades to go before we get the real truth.
But it's really, it's just so fascinating when you think about the inter-organ crosstalk between muscle mass, the brain, everything, in terms of how do we become more robust in a world that's not perfect?
Yeah, absolutely. And that's what I think is so fascinating about all this, very complex research, is like, finding ways to essentially re-engineer the system, or like biohack the system to work around those factors.
Have you looked at particular kinds of exercise, whether it's high intensity interval training? I don't know how much you do with exercise, but is that something that you've explored in terms of its relationship to sleep deprivation?
So that isn't something that I've not explored that. There's been a few studies though that have, and it is actually the HIIT workouts that, when I'm talking about that 1 to 2 hour period of improved performance under sleep loss, you're going to get that more from a HIIT versus cardio, because
and what about lifting?
Lifting too, right? Because of the increases in epinephrine, and cortisol that naturally come with that in ways that, you just can't get from cardio.
When you think about biomarkers for health, because you are looking at a lot of blood work, you and I were chatting about Inside Tracker before, what are some of the things that you have found useful in individuals that have to go and perform, or even yourself, whichever you feel like sharing?
Yeah, sure. The two things we really care about, because, right, this is the crux of whether you're in an anabolic or a catabolic state, is testosterone and cortisol, and what the ratios of those are. Sure, the amount of C-reactive protein is also important, because it's going to determine your overall, physiological stress status. But I think it's back to the basics of looking at what those ratios of cortisol and testosterone are, because that's going to drive your recovery, and also it has an impact on nighttime sleep. Right? We know people with high high cortisol, low T, they are unable to get that restorative slow wave sleep that primes and contributes to testosterone release. And so it's a vicious cycle, if you will.
And this is, are you guys looking at these numbers, testosterone and cortisol?
Yeah. So I don't look directly at them, but the providers and physicians who do, when they do blood work, those are like the two things they focus on.
Do they talk about, or have you discussed the ratios in particular of, the number of the ratios or things of that nature of the testosterone cortisol ratio?
No, I haven't. But I like I said, those are like the two main factors that they're looking at. So when they're allowed to.
Yeah, that's right. True. All very true. What are some of the things, other biomarkers that you think about when you're getting blood work or thinking about blood work or looking at, say, the soldiers? Are there other things? So we have, there's obviously genes, testosterone and cortisol, HSCRP, anything else that's on your mind. And basically the question is open to blood marker, heart rate variability. What are indicators that someone is in good circadian alignment?
I think the other, just thinking from the perspective of sleep, the other thing that a lot of people forget about is sleep continuity. So sleep efficiency, right? Sleep efficiency is essentially how long of your time in bed are you actually asleep? We know that in individuals who do experience circadian misalignment, shift workers, perfect example, that they have poor sleep efficiency because they're constantly trying to sleep at times that aren't aligned with dips in the circadian clock, or they're trying to sleep at times when their clock wants to be awake.
And the body can never train to do that, right?
Right. Yeah.
I mean, so
no,
this
it doesn't.
is
You're fighting against evolution and biology.
So you either are a nocturnal creature or you're not, and we are not nocturnal creatures.
Exactly. We will never, even despite our constant push to be vampires and to be night shift workers.
Speak for yourself. I'm like 8:30. Good night.
They like the human. I do not see human evolution evolving to that point where we can become nocturnal. We were, evolved to be diurnal creatures. And so that's what we use a lot of times as a marker of, one, circadian alignment, misalignment, but in theory, like general sleep health, right? And you talk about HRV, if you look at trends and heart rate variability and you look at sleep efficiency, anytime sleep efficiency is low, and by low, I'm talking like less than 85%, you're going to have low heart rate variability. That's, it's far better to get, as we say in like our operator world, like it's far better to get 5 hours of deep restorative sleep where you're awake or where you're asleep the whole time than it is to be in bed for 8 hours and only have 4 hours of sleep. That isn't really restorative sleep.
Are there tools that people can use to tell that they're getting good sleep efficiency, like the Oura Ring or Whoop? Are there things, or does core body temperature play a role in this? Any of those things that the listener could think, okay, well, I get that sleep is important. I also know I need to hypercaffeinate myself, get blue light in the morning. How could they determine if they are getting good sleep or effective sleep, right? That they're, because, I guess it's not about the sleep per se, it's about the whole person and how resilient, because you had mentioned something really interesting on another interview you did that, for example, presidents have seemed to be a group that have self-selected for a gene mutation that allows them to get 4 hours of sleep and be great.
Yep. I would argue that most generals and admirals are the same too. That's why I'll never be one.
That's crazy.
Yeah.
I mean, there is do we know what those genes are that require less sleep?
Yeah. So one of the genes that has been widely studied, again, in preclinical animal models and then relevant human studies is the gene DEC2, so DEC2. It is the short sleep gene. So in humans that have been shown to naturally have single nucleotide polymorphisms in this gene. Only require 2 to 4 hours of sleep at night, and otherwise,
what percentage of the population is that?
No, there's probably some genetic trade-off, right, that we're unaware of.
What do you mean, like
maybe there's some related disease state where they don't actually, like maybe their lifespan actually is shortened or so. I don't know. I just
it's crazy. I do know. I have one patient that when I first started taking care of him, he was like, "I get 4 hours of sleep." I'm like, "Well, aren't you tired?" He's like, "No, I've been that way my whole life."
Yeah, I meet operators all the time like that.
4 hours of sleep? Are you bananas?
Yeah, they're out there. It's less than 1% of the population.
Less than 1%.
That's what people need to remember. It's like less than 1% of the less than 1% of the population has this SNP. From what we know from this genetic landscape study that these researchers did, just like we know 10% of the population are true genetic morning people, and the other 10% are true genetic night people like I am because of these SNPs and these clock genes. But yeah, I think, that's why it's so important, again, to do biomarker capture, to do things like Insight Tracker, to get a genetic screen done so you can figure out who you are as a person and then work and plan your life and train around that. I mean, that's like we were talking earlier, that's essentially what I did when I did 23andMe at least 13, 14 years ago. I initially did it because I have a strong family history of Alzheimer's, and I wanted to see if I had the ApoE4 mutation associated with being of Eastern European descent. I don't have it for some reason, which is crazy, but I did find out I am a true genetic night owl. And I also found out
And was that from the DAX2 gene?
So this is actually from one of the circadian clock factors, so PER2. So a SNP in PER2 is associated with being a night owl. It's the same too for being a morning person. It's just whatever the SNP is. But then same with CrossFit too. It totally explained why I've naturally fell into CrossFit after track and field and gymnastics, is because my body is genetically made to do like mixed modal endurance anaerobic exercise. So
I mean, it's pretty extraordinary. What about do you think there are tools that we can actually use to improve our circadian alignment? And do you think that that's the right word to say? Is it really circadian alignment that we're looking for? Okay.
Yeah, circadian alignment. You mean, right, you have the like we talked about, the homeostatic component of sleep, where you have your sleep set point. Most people it's 7 to 8 hours, but it's the circadian alignment piece that a lot of people forget about and can be the most damaging. I mean, there's reasons why we know chronic rotating shift work cuts 10 to 15 years off lifespan.
That's terrible.
Right? Rotating shift work.
What does that mean? That's you're just not consistent with it? You're going to various...
So people are doing rotating shift work, right? They're going from night shift to day shift to swing shift. It's better if you're going to be a shift worker to stay on night, to stay on day. That's kind of the same thing they kind of do though with operators, right? Like very, very rarely do they shift them off that shift, especially when you talk about like aviation and pilots and things like that. Most fatigue related accidents in the aviation community that we're aware of are because of these rotating shifts. It's just that circadian misalignment and realignment is just so physiologically damaging to the body. How
do we stay aligned? Is it wake up at the same time, go to bed at the same time, use blue blocking glasses? I don't know, hit some Rippets and energy drinks. What do we need to do so that at home in a non-perfect environment, we can improve our circadian alignment?
So really, you don't have to do anything fancy. Like it's as simple as waking up the same time every day, going to bed the same time, having those photic and non-photic cues. So like I said, my graduate career was spent studying the neurobiology of these non-photic cues. So exercise, social interaction. We didn't study food presentation, but the timing of food. So
Tell me about that.
So not so much like the quality of
Macros,
food,
yeah.
but like, so one of the oscillators, like circadian oscillators that's been identified is called the FEO, the food entrainable oscillator. It lies in the hypothalamus, and essentially, if you're on a structured schedule, your hormone profiles that increase hunger signals and all the physiology around that will start being aligned around anticipated food presentations. This is something we've seen again in preclinical animal models where the environment's completely controlled. We also know there's a REO, a reward in training oscillator. So presentations of both positive and negative rewards will entrain the circadian clock.
And how can we think about that? A positive or negative reward? Food reward or dope? I mean, what are we thinking about?
Yeah, so it's all dopamine driven. So that's where social interactions come into play. So like even in preclinical animal models, like they are social creatures, right? And they have social environments, but exercise can also go in that category as well. Anything that we consider rewarding, like sure, you can go down the dark path of drugs of abuse, but
we're not going to do that.
No.
In terms of the alignment, it doesn't sound like it's anything fancy. Is there wiggle room? You could go to bed 20 minutes later. It doesn't have to be exact. Is there?
Yeah. So clinically, what I know is done with, for example, CBTI, so cognitive behavioral therapy for insomnia. When you are trying to help people extend their sleep duration or get on a sleep schedule that works for them, they're adjusting and flexing within 20 and 30-minute intervals. So at no point throughout, like, for example, a sleep extension protocol where a patient is trying to get more than 5 hours of sleep and just hasn't been able to on their own, the therapist or psychologist they're working with is only extending their sleep duration by 30 minutes at a time for a few days, and then they'll increase it to 30 minutes longer after that. Like it's a gradual increase by about 20 or 30 minutes. So that is the sweet spot actually for any sort of adjustment without creating additional stress on the sleep circadian system.
And what do you say for people with jet lag? Are there ways to manage jet lag?
Yeah, so that's actually where the like fancy technologies and tools come in. So I have a friend, he created this app. He's a well-known circadian biologist, was at Harvard. He might still be there. It's called Time Shifter. So essentially you put in your flight schedule and it gives you a day by day thing to avoid or to mitigate jet lag. You can't ever fully treat jet lag in my opinion. But exercise coupled with napping, melatonin, and then blocking light at certain times. Those are really the 4 ways to prevent that. And then, yes, we do work with this company now. He's a good friend of mine. FlyKit is the name of the product, where they use a combination of blue light blocking glasses combined with a formulary of products known to reduce inflammation, because we know in the act of reducing inflammation, you can reduce the amount of circadian stress, because the circadian clock is intimately tied to inflammation.
I think it's crazy, this idea that systemic inflammation or even low-grade inflammation would affect sleep and vice versa.
Oh, yeah. So it's actually what we've shown in preclinical animal models, it's actually lethal. So
what? Wait, what?
Yeah. So my very first project as a postdoc, there was a researcher down the hall. This is his area of expertise, is looking at the intimate relationship between the circadian clock and inflammation. His name's Dr. Alec Davidson at Morehouse School of Medicine. And when he was a postdoc with the field's great Dr. Michael Menaker, who's no longer alive, basically they gave an LPS injection, so lipopolysaccharide.
Yeah, which people would think that that's one of the byproducts that people think when they're eating a bunch of bad food, that this increases.
Yep. to mice, and essentially they had like rapid deaths, like as soon as they were like their light cycle was phase advanced. So every week he would phase advance their cycle. So essentially it'd be like traveling from East Coast Boston to a flight to London every week, and like the mice who were injected with LPS were dropping like flies. And so we wanted to do a study to separate out this circadian component from the homeostatic component to sleep. Is it the actual phase shifting that is causing this increased mortality in these mice injected with LPS, or is it the insufficient sleep that they're experiencing? So essentially what we did is we were able to figure out how much insufficient sleep these mice were getting under this 6-hour phase advance. And so without shifting their circadian light cycle at all, we just essentially sleep deprived them at that amount. So that's all they did, was they got equal amounts of sleep deprivation day after day that they experienced under these 6-hour phase advances. And then the second group, we replicated the experiment that he did many years ago, where we just essentially phase advanced these mice, injected them with LPS prior, very limited mortality under insufficient sleep, lots of mortality under the 6-hour phase advance. So from my perspective, like what we've shown in preclinical animal models, circadian misalignment is far more pervasive and dangerous of a problem than insufficient sleep itself.
Shoot. The take-home message is wake up, go to bed at the same time. I suppose even if it's not ideal, right, for sleep. But that makes me think, if I'm really tired, like just take this for example, would it be okay to sleep in? But now you're maybe waking up later, changing all of these things. How do you weigh out what you do versus what is going to be most beneficial? Do you just wake up at the same time and still be a little bit tired, or how does that happen?
It's so, and I think you've pointed out the complexity, right, of this. Now, when we are doing these studies, right, you're talking about extreme differences in light dark schedules, right? But when you're talking about insufficient sleep, the thing you have to focus on most is insufficient sleep is challenging the homeostatic component of sleep. And you need to fix that before you can address the circadian component. That's why, and the population of chronically sleep deprived soldiers and warfighters I work with, like, it's better from our perspective to pay off that homeostatic sleep loss than it is to address, before we can even start to address the circadian system.
Meaning you don't care if they're waking up, getting blue light, eating at the same time. You just want to get them sleeping.
Exactly. And there's a study that came out a month and a half ago by a group of researchers from Asia, that people who were insufficiently slept during the workday, who work week, who slept in on weekends, had a 20% reduction in heart disease. So this is a longitudinal study that was done.
So basically get them sleeping. I didn't, but maybe you can send it to me. I'd love to see it.
Yeah.
I'm going to show it to Shane, and then he's going to say, see, now I guess I should get to sleep in. Talk to me about stimulant use. Talk to me about nicotine, anything else. Asking for a friend, Matt, producer, I'm just going to pin it on him. But things like stimulants, bright light, loud music, those kinds of things to maybe help overcome sleep debt just to be able to perform.
Yeah, I mean, that's the stimulant piece is something that I think we have strategically mastered within the Department of Defense.
You have to talk about that, and you have to back that up by talking about an energy drink.
Yes.
So tell me about stimulant use, like nicotine, those kind of things.
Sure. So caffeine we know is very effective. Full disclosure, when we were doing caffeine in our studies, we were using caffeine gum. So the Department of Defense years ago at Walter Reed, they developed an actual caffeine gum. It has 100 milligrams per piece. So when we were doing the studies of dosing 100, 200, 300, we were basically giving them like.
Did you ever try that gum?
Oh, actually, I carry it. I should have brought it here today. You can buy it online. So
Is it called What is it called?
It's called Military Energy Gum.
Okay.
It's available on Amazon. Honestly,
scale of 1 to 10, how good do you think that tastes?
So if you get the wintergreen one, it's not that bad.
So like 3?
I would say the wintergreen is like a 7.
Okay.
The spearmint is a 5, and the cinnamon is like a 1.
Okay, so that's a hard pass. I was hanging out with our mutual friend Nick Barringer.
Yeah, he has that.
Yep, former. He did retire, Ranger. And I was like, dude, I need some caffeine, and I got a piece of that gum. Made me want to vomit.
Did he give you the cinnamon?
Probably with cinnamon and the I just wanted to, for anyone who's running for caffeine gum, please let's develop one that tastes marginally better.
Yeah. So not to derail this, but there's actually a story about the form factor of that gum. So it used to be a contract through Wrigley's. So it's stick wrapped in foil. Well, when they started giving that gum to soldiers it's been around since the Gulf War, like it melted in their pockets. So that's actually why they made it chiclet form. And so I've used that gum while deployed overseas all the time in, 120 degree weather.
All right. I'm sold on it, but I'll try it.
But no, technically, like we were just talking about Zen, right? Like nicotine can have neurochemically the same effect as coffee or other sources of caffeine in terms of promoting wakefulness, because ultimately what is happening is increased acetylcholinergic release, particularly within the basal forebrain, for example. And like alpha GPC, I tried to do a clinical trial with alpha GPC when I was at Walter Reed, and it wasn't funded at the time.
For the listeners, is a compound.
It's a compound that, quite honestly, it's a first order effect on wakefulness, right? Because alpha GPC is a acetylcholine agonist.
And it's well studied.
Well, it hasn't been well studied because, the FDA, we all know that there's restrictions within the FDA on supplements and studying them and, clinical trials.
But you like it. You personally like it.
Yeah, personally like it. And I believe like neurochemically, that may be a better first line of defense than coffee. Because if you think about coffee and other sources of caffeine, what happens? It inhibits adenosine receptors, which downstream effect is increasing acetylcholinergic tone. So it's an indirect means to increase acetylcholinergic tone, whereas alpha GPC is a direct impact on acetylcholinergic tone. Bottom line being that any source of caffeine from energy drinks or coffee is going to have the same effect in the brain, right? Blocking the adenosine 2A receptors. Nicotine will also increase acetylcholine directly, because what is acetylcholine? There's 2 receptor types. There's nicotinic and there's muscarinic. Mm-hmm. So it's acting directly on the nicotinic acetylcholine receptors.
Do you guys,
without getting too nerdy?
Well, yeah. Do they? Oh, we'll take it. Do they use that in the protocols for operators, or not necessarily?
No, our protocols have just been focused on caffeine.
Just the operators use it themselves.
Yeah. You know what though? I never had any intentions of like dipping until I came to special forces. But you know what? I do like Zen. I every so often now, I can't help myself. I'll put in a Zen pouch. So my wife hates it, but
you sound like our producer Matt here loves the Zen.
They make coffee pouches now, actually. So Black Rifle Coffee, they have like little coffee pouches. What? Yeah, I use those too.
Well, Evan, you better send us some. We'll take it. I will definitely try that.
Yeah.
Talk to me before we wrap up. Talk to me about energy drinks.
Sure. Yeah, this will give me an opportunity.
Yeah, we're giving you a platform, an opportunity to explain your stance on energy drinks.
So when it comes to different caffeine sources, right? In a certain environment, like you have what you have. So, right, when we were deployed and there's rippets around, like that this sounds dramatic, but it's true, like could be the difference between life or death, right? Because that amount of caffeine can be the difference between having heightened vigilance under circumstance that requires it versus not. The issue I have is with chronic energy drink consumption, which was done in a very carefully controlled longitudinal study. And then I can talk about like preclinical animal studies as well. So
the floor is yours.
So the study that I am referencing that has been a hot area of conversation is oftentimes during wartime situations, they deploy us as part of, they're called mental health advisory team. So I was a part of a mental health advisory team during the war in Afghanistan, where we went out with the 1st Armored Division to capture their state of mental health. So in our particular circumstance, we were looking at how much sleep these soldiers were getting in these far forward deployed settings, and would correlate it with certain time points in military performance. We did subjective clinical validated questionnaires of mood, energy, risk factors for different mental health issues, etc. So I'm setting the stage. So there was a mental health advisory team that went out with the 3rd Infantry Division. So we're talking an entire division of soldiers. And one of the things that the mental health advisory team did during this time was look at the current state of energy drink use and consumption on deployment. And so what they did when these soldiers from the 3rd Infantry Division redeployed, so we're talking about almost 700 soldiers here, they looked, with keeping everything else equal, counterbalancing all these other confounding factors, they found that soldiers who had consumed 2 or more energy drinks on deployment had increased risks on the clinical inventories of PTSD, anxiety, depression, fatigue, aggression, and burnout. So that is essentially, that is the study in its essence, where there were means and ways to control the environment. So look at redeployment and factors during the deployment that impacted these risk factors for mental health, which the number one factor in this case that they found was soldiers who reported drinking 2 or more energy drinks on a given day during deployment.
Why do you think that was? What do you think it...
So this is where we can glean from preclinical animal models. So there are a few studies that have been done, and I know some of the criticism for this is that the high dose of energy drinks that were given to these preclinical mouse models. But what it did do was
it just caffeine, or what were they?
So they actually would give these preclinical mouse models energy drinks.
Okay.
So when I was in grad school, we used to do studies all the time around drug addiction and the impact on the clock. Mice will drink cocaine, like in water. They will drink cocaine. They will drink heroin.
Oh my gosh.
They will drink energy drinks. They will drink anything you put in their water. Okay. So these studies have found when you're looking at histology-based signs of neurotoxicity, so using a microscopy factor of neurotoxicity, increased neurotoxicity as identified post-mortem from a preclinical mouse model that was given energy drinks versus not given energy drinks. And then there was one study where they were looking, it's a technique called voltammetry. So basically you're looking at increased activity in presynaptic and postsynaptic glutamate release. And they found increased voltammetry in these mice that were given energy drinks. So that's the mechanism of action, is it's hypothesized that there is an increase in presynaptic glutamate release onto the postsynaptic neuron that creates the condition of neurotoxicity.
I think that is well explained.
Okay.
Do you feel good about this explanation?
Yes, I won't ever say electrocutes the brain again.
But listen, all we all say statements like that at some point. But
Yeah.
Dr. Allison Brager, thank you so much for coming on the show. I think the work you're doing is really phenomenal, and I hope to see you in space.
Yeah, hopefully. That's right. I'll come here and make sure I stay with you, and I'm in training, hopefully.
Soon.
Yep.
So when will that be? And they probably won't let you stay here because it's about 40 minutes from the Space Center. But
yeah, that is true.
But you are welcome. When do you think? Tell me a little about this astronaut selection.
So this is my second try in the pipeline. The pipeline's every 4 years. I was a semifinalist for the last class, so I made it to the round of 120. That's after I believe they had over 18,000 people apply last time. I have heard that there were over 25,000 people who applied this time. So right now they're trying to figure out how to get it down to the 120. So I'm hoping I make it, but at the end of the day, I did get good advice. One of my mentors is retired SEAL Navy Captain Bill Shepard, who commanded the first 4 missions on ISS. He said a lot of times, like, it's about finding that right person for that right mission. And so, I'd like to think if and when our NASA needs a neurobiologist, like, I'm the one they call. But at the end of the day, I've met great Americans, right? Like, I have this network of people that have just done incredible things in life in so many different areas of science and engineering and medicine and society that, like, if it never happens, like, yes, I'll be disappointed, but at the same time, like, I've met so many great Americans through it. So,
well, you are definitely all about the team. So,
yeah,
Dr. Allison, thank you so much for being on the show.
Yeah, of course.